Welcome students, this is Chandan Singh Negi. In previous classes we have discussed this is iota powers and how to write it in the form of a plus iota b or x plus iota y. Right, now we are going to solve this one. The two complex numbers are equal if and only if, or like we have two complex numbers x plus iota y is equal to a plus iota b if and only if x is equal to a and y is equal to b. This one, right? See this one. I have let this is x minus x plus iota 3 is equal to 4 minus iota y. Then what is the value of x and y? That is the question. Find x and y. This is find x and y. Now see, this is x. Let's compare this one. This is x plus 3 iota is equal to 4 plus minus y into iota. That is plus sign, and here is also plus sign. See, this is x in place of x. That is the real part must be equal to real parts. That is x is equal to 4 and imaginary part is equal to imaginary part. That means 3 is equal to minus y. So that is the solution of the equations. That is the solution of the questions. Now see the second thing. Now we will discuss the algebra of the complex numbers. Algebra of complex numbers. Algebra of complex numbers. Right, this is complex numbers. Okay, right, this is also. Let we have complex numbers, or let Z1, Z2 and Z3 are complex numbers. These are the different complex numbers, right? In algebra of complex numbers we have, this is we will discuss this one. The first part is that is closure property. Closure property. And second we will discuss commutative property. Commutative property. Commutative property. Right, let's write this out. And third one is associative property. And fourth one is existence of identity. And fifth is existence of additive inverse. This is additive identity. And additive inverse. See, these things you have been studied since the childhood. That means since I hope from class 6 or 7 and 8, right? But I knew that this lot of students miss these things. They feel that this is not for us. This is not made for us. As a mathematics students, understand these things. Right, as a mathematics students, understand these things. All these things, the same things you have been studied in the past. This is a couple of years, right? See, the first thing, the closure property. In earlier classes, you have studied that if see this one, if the integers are added to integers, then what will be? This is the integer, right? If I add the real number to real number, that will be a real number. Like see this one, this 1 plus 1 is equal to 2. The 1 is integer, 2 is also integer. That property is called this one closure property, right? If I call that this is one irrational number is plus is irrational number, then it is a rational number. right? But if I call this irrational number minus irrational number is irrational number, and then closure property does not satisfy, right? See this one. The first one is closure property. Closure property. What does it mean? You have to understand this one. If the numbers is which is elements of the same kind of numbers, then if we add these numbers and then the result must be the same kind of numbers. Like this is if z plus z, that means if the complex number is added to the complex number, then what will be the answer? This is complex number, right? So that is complex number. That is complex number satisfied. This is called closure property for additions. And now the second thing, this is for addition, or I just writing both for the addition and multiplication, not wasting the much of time. And this is for addition. And second part is for multiplication. For multiplication. That means closure property for multiplication means if integer is multiplied to the integer, then what we will get this integer, right? The integer into integer, we get integer. Now the same thing here, if z into z, or z1 into z2, if the two complex numbers or same complex numbers is multiplied, then the answer will be complex number. The answer will be complex number. That means closure property satisfied for the complex numbers for addition as well as multiplication. I'm just giving you the example of this one. Like this is 1 plus iota plus 2 minus iota. It is equal to, this is just like this is 3 iota. I am just writing this one. It is 3 minus 2 iota. So that is complex number, this is complex number, this is complex numbers, right? And second one is if I multiply these two complex numbers, let me just focus this camera. Let me right. See. This is complex number into complex number. Like this is iota into 1 plus iota, right? This is iota into plus iota square. This is equal to minus 1 plus iota. This is complex number. If this is iota into iota, that is iota square. This is minus 1. This is again this is minus 1 plus 0 iota. This can be as a form of complex number, right? Now that is commutative property. Again, the same property which we have studied for a couple of years. See, the second is commutative property. Commutative property. Commutative property, that means interchange the order of complex number. Like Mr. A is roll number 5 and Mr. B, which roll number is 6 or 7 or 10. Or like this is Mr. A roll number 5 and Mr. B roll number 7. Now, if I change these two roll numbers, now I'm just changing this one. Now Mr. A is 7 and Mr. B is 5. If I interchange these orders or these roll numbers of Mr. A and Mr. B, what will happen? Whether their identity will be changed, their face will be changed, their haircut will be changed? No. Right? That means the commutative property hold that if I interchange these two numbers, that means I am talking about the order, if it does not change, then that is called commutative property hold. Let's see this one. Z1 plus Z2 is equal to Z2 plus 1 Z1. That means commutative property. If I write Z1 first or Z2 first, then the answer will be same and answer does not change, right? Check it at home. I give the examples. Iota plus 1 plus iota. This is equal to 1 plus iota plus iota. This is equal to 1 plus 2 iota is equal to 1 plus 2 iota. That is does not change whether the left hand side or right hand side. Now for multiplication, so if z1 into z2 is equal to z1 into z2 into z1, that is the commutative property hold for the multiplications, and that is commutative property hold for addition. So there is two things. This is multiplication, and that is hold for addition, right? So check it at home. The z1 into z2, write z1 any complex number and write z2 any other complex numbers, and then multiply first z1 z2 and then z2 z1, right? Now the next one is associative property. That is associative property. Okay. Next one is associative property. Let's check this one. Check this one. Let's erase the first part. Associative property. Third one is associative property. Associative property. That is just like associations. If two friends are friends to a third one, then all three are friends. First two friends are friends to third one, or third one is friends to second one. Like this is just giving the example. This one, like this is A, B, and C are three friends. If these two friends are already right. Two are friends, and then they associate with this third one, so then all three are friends. Or A is associate with BC, which is already friends, then it does not matter. In both the cases, all three are friends. Here, if Z1 for that is for writing associative property for this is for addition, right? So Z1 plus Z2 is already friends, and Z3, this is equal to Z1 plus Z2 plus Z3, right? So Z1 plus Z2, this is plus Z3, is equal to Z1 plus Z2 plus Z3, right? So these are the same thing. So this is the first two are associated to third one, or first one is associated to second and third. So then the answer will be same. And same for this is addition. This is addition. That is the homework. You just write the different complex numbers and verify these one whether this is correct or not. If it is incorrect, let me know or write to message me. Right. That is for multiplication. I just writing this is multiplication. This is Z1 into Z2 into Z3 is equal to Z1 into Z2 into Z3. That means first multiply Z1 and Z2, then Z3, and the same thing Z1, first multiply and then Z2, Z3. Now the next one, this is fourth part, we have additive identity. This is additive identity. What happens if I add something on you so that your identity will be remain same, right? The same thing if Z plus 0 added, then the identity of Z, that means the Z does not change. This is called additive identity. The Z will remain Z. Or like example, this is 1 plus iota plus 0 iota is equal to same. This is 1 plus iota. So Z plus 0 is equal to Z. Right? So that is called additive identity. And multiplicative identity, anything. This is additive identity. And this is multiplicative identity. Just assume this one. This is Z into 1 is equal to Z. Right? Now this is fifth part. This is additive inverse. This is additive inverse. Additive inverse. Right? This is what happens if the opposite of the z is called additive inverse of z. So if I z plus minus z, if I add, then we will get this is 0. So this is called additive inverse. Minus z is called additive inverse of z. Right? Or z is called additive inverse of minus j. Right? The next, thank you students. In next sessions we will solve some more problems or concepts. Right? Thank you.